ask one very simple question. How long you can live without your mobile phone? I'm not asking days because this is too much, but hours. Please tell me. 1 hour? Not even 1 hour, because you will feel so much stress. Where is your mobile? Why? It is our lifeline. Everything is inside the mobile. Your certificates, your lectures, and everything you find through this. But I want to just go inside the mobile, leave the software part apart, then see what is in that hardware. What is this hardware? Chips, semiconductor chips. And I'm talking about your friend, which is very tiny in size. What is that? A transistor, which is making circuit, and finally it is making chips. Okay? So when I talk about transistor, can you know what is the size of transistor in today's technology? What this Apple iPhone I am having? It is 14. Can anybody tell? Anybody is from electronics course program? Who is making circuit using these transistors, doing simulations? Yes, no? Nobody? Yes, 5 nanometer, good. So, can you think what mobile I am having? It is having one chip. How many transistors are there in that chip? No idea? Okay, let us take the example. I am showing you 3 more powerful chips of today's. First one is Apple M3 Ultra, your Mac Studio. Do you know how many transistors? 184 billion transistors. One transistor has 4 nodes, all are connected. So 148 multiplied by 4, that is the connection we are having in a chip. By mistake, I am not able to simulate properly. Then what I have to do? I have to change the parameter. I will again simulate it. It will take hours. No, it will take days. And sometimes, if I want to verify, it will take months. And all engineers are working day and night for doing the verification, for making the chip. Second one is AMD MI300A. It is having almost same, 146 billion. And third one is NVIDIA. I hope everybody is familiar with NVIDIA, because it is AI platform. And you are very much familiar with AI now. It is having 104 billion transistor. Notes I am also writing. But see the part which is very important, that is chip size. These transistors we are fitting, first one, 848 millimeter. बनाइए जरा अपने हाथ से, कितना बड़ा चिप होगा ये? 848 millimeter square area. And how many transistors? 184 billion. कितना हो गया? बिलियन कितना होता है? Anybody knows बिलियन कितना होता है? मिलियन जानते हैं? उससे तो बड़ा ही है. ओके. इतने ट्रांजिस्टर्स को एक साथ रखकर and getting the required performance is a big task using conventional and traditional methods. What are these methods? Our EDA companies, they are giving the softwares to run, to do simulation, to do verification. Then there are fabrication industries which are fabricating the chips, and finally packaging, and it is going in the market. And as I mentioned, if you change anything, it takes lot of time to again re-simulate or doing the process again and again. So to get performance in less time, what is the solution? So I also use in VLSI area that solution is use the emerging technologies and AI is the one. AI क्या करेगा circuit बनाने में? It is algorithms. ये क्या काम कर लेगा? ये circuit थोड़ी बना सकता है? No, it will help us in many things. If I give real data, AI works on the data. Train it and get the answer. So similar fashion, I will give real data to AI algorithm and tell, simulate it. First and I will get the result. So my iteration time reduces. That is the only way of using AI in VLSI. So we are having now, in place of simple chip design, I'm concentrating only design, not fabrication and after that. Now we tell it AI-driven chip design. At 3 level. First level is AI ML in EDA tool. Definitely they have to support us. Only then we will do the simulation. So they are having tools. Through these tools, what we do automated placement, automated routing, optimizations, verification. One example I am giving, Google DeepMind. That is the tool produced by Google. This gives us floor planning using AI-based algorithms. So I'm not using traditional floor planning method, which is again algorithm-based, but it is AI-based. So I'm giving real data. By looking all these data, it will give me best floor planning for the chip. Second is AI-specific architecture. If architecture is not there, what we will do? So we have to make that type of architecture, tailored architecture, TPU. That is again Google is giving us. NPU, TPU is tensor-based processing unit. Maths is coming in that. And NPU is neuromorphic, brain type of the methods we are taking, neural networks. And then we make domain-specific SOCs. ये security का SOC नहीं है. It is system on chip. And third one is generative design. That means algorithm, it should learn from the data, update its learning, and then do. One open question I give you. We make the layout. Circuit is what? Layers. Different type of semiconductor layer, metal layer, oxides, all these are there. Can we make layout using AI? Can AI algorithm help me to put the layers and make the sandwich of layer which can result in a circuit or in a chip? This is open research problem. If anybody wants to do research work, please come to me. We will work on that. So it is unsolved problem. People are looking for that. If we give real data, kindly make layout for me, which is not possible as of now. People are working on that. But many tools which are basically algorithmic based, for them we are using AI. I'm not going in much detail of this. These are the design flow, and each design flow we have challenges, different type of challenges, how to use maximum memory, how to calculate power, performance, then synthesis, predict timings, spaces, constraints, growing design complexity, how to handle. All these are the challenges at each level of VLSI design. These are the solutions. So different algorithms are there. People are already using all these algorithms in the design and taking the advantage of AI. The only challenge as a researcher we face is that we are not having real data. Unless you give correct data, AI will not work. and real data is from the chip. No industry, even no fabrication lab is ready to publish their chip data publicly. So this is the biggest challenge we face when we are using this type of AI algorithms using to find out the solutions. Some dummy data is available, but we cannot guarantee with dummy data that the final result is correct or not. So if somebody is able to get the real data of the chip, definitely these solutions are very good. And in future, I believe that at least EDA tool will be more close to the real data, because they are having the library files from the foundries, and these library files are basically the real chip data. So they can predict more accurate result using AI than simple researchers who are working on the dummy data. So I will not take much time. I will only say that with the fusion of VLSI and AI predictive analysis, again, please give some attention on this predictive analysis. We are going for that. Complex but more reliable and efficient hardware can be built in a short time. So we are trying. If anybody is interested, please come to us. We are having a very good course on AI and VLSI, in which you will learn how AI algorithm can be used at different level of VLSI design, starting from chip specification to simulation, finally fabrication and verification. Thank you.